So go ahead.
All right, hello everyone, and welcome to our Colloquium series. It is my pleasure to introduce Dr. Matthew Lazzara. He is actually an alum from our department here, did his master's and PhD here. And he's now a senior scientist and research meteorologist at the Antarctic Meteorological Research Center, or AMRC, which is here within the SSCC here in our building. And I know he's going to talk about this quite a bit today, but he is the principal investigator of the Antarctic Automatic Weather Station program. Did I say that right? Or AWS. So he works a lot with supporting and maintaining the generation and the archive of Antarctic weather data collected by the AWS network, as well as Antarctic satellite composite imagery. And you're also faculty at the Madison Area Technical College, where he teaches in weather and climate. So thank you so much for giving this talk today, and we look forward to what you have to say.
All right, thank you. Welcome everyone. Glad you could come along today. Thrilled to have you along. So let's talk a little bit about Antarctica for the next hour or so, about some observing, a little bit of archiving, definitely the extremes, a little bit of means, and so forth. Please note, what you're going to see is not just me. All of the effort we're going to talk about this hour is done by a team. This team of people includes folks from right here at UW-Madison, as well as folks at Madison Area Technical College. So welcome to the team, and this is a sample of them. We'll give you a little bit of background about me and give you just a brief welcome to coming along today. Yes, we're going to talk about the Automatic Weather Station Network, something that the University of Wisconsin has been well known for a long while. We should talk about our field work and what are we doing with the data. A little bit of applications to give you at least a little sample, a little taste along the way. And something new, data repository. What it's like to be in Antarctica, and we'll close it from there with a few interesting folks that I've had the chance to meet up with. So that's what we're going to do for the next hour. So a little bit about me. You should start here. It's very special when a meteorologist gets to have their first weather balloon, and this is me with my first weather balloon at the age of about 3. Yes, this is in Massachusetts, John. I did my undergraduate work out in Linden State College, now Northern Vermont University at Linden, and some of my faculty there were graduates from UW-Madison. So I came here to work, and I was really excited to continue my graduate work here and have my teachers, which was really exciting to me. I have the of being not only a scientist here at SSCC in the building, but I am indeed faculty, as noted, out at Madison Area Technical College. I'm the department chair for physical sciences, and I've been there full-time now since 2014. The research work we do is mostly funded by the National Science Foundation, so a tremendous amount of what you're going to see is there. I do get a little bit of money, a little bit of work we do at SIMS. We're very excited to work with NOAA on some of our composite work, which I'm not featuring as much today. And we have had the opportunity to do work with the Weather Forecasting Group in the U.S. Army program, which is run by the Naval Information Warfare Center. They're a part of the United States Navy. Oops. Some of the professional work that I get to do involves the Scientific Committee on Antarctic Research. So the Antarctic is basically run under the UN, right? And the scientist part is this thing called SCAR. I'm also the president of the International Commission on Polar Meteorology, which is covers both poles, and we get really interested in putting on it basically science symposia for basically Arctic and Antarctic work, which is pretty exciting. So a little bit about me. But I would not be here without this gentleman. Thank you, Stephen. I'm glad you're appreciative of this. Dr. Charles Stearns is original gentleman to really work on a lot of the foundation that everything we're going to talk about today comes from. Dr. Stearns was a professor here in the department. He had a long history with UW-Madison, over 67 years. And he pioneered some things that, at the time, were novel and new and exciting, even though we all take them for very granted. Sharing data. Chuck was giving data away long before it was hip and cool to do that. And that was a really neat thing about him, and he was very interested in a lot of collaboration in work, and we've continued that spirit in my team ever since. So this is the thing that we are best known for in our team, is building, installing, maintaining, fabricating a network of automatic weather stations in the Antarctic. Dr. Stearns worked on this work starting about 1980, and my team has continued to work on it ever since. And we've been doing it, yes, this January will be 43 years of this work. And starting all the way back when he took over the project from Stanford, this is the original Wisconsin-1A stations, all the way to the stations that we now have today, which include one that we're going to talk about a little later, that's a joint project between Madison College and us here at UW-Madison. These stations do the basics. So we get the temperature and the pressure and the wind and relative humidity, right? Nothing fancy. We've started to add a few, more collections. We're getting snow accumulation next to the station or incoming sunshine. The newer project that we're going to talk about in a few minutes here is we've started to build these polar climate and weather stations. It's really mostly the electronics core that we're working on, but if we get these to work out, we're going to start collecting, if we can, 4-component radiation. So incoming and outgoing shortwave and incoming and outgoing long-wave radiation. Probably won't be super perfect in the Antarctic because things will get a little frosty and a little dirty when we're not there to clean them off. But in any case, we're excited about keeping up with some of the exact same sensors we've been known for using for a long time and adding a few more additional measurements along the way. This is what they look like when we're out in the field. So you can see here a classic system set up with the wind at top, relative humidity, temperature. We have a second level of temperature. Here you can see the incoming sunshine and acoustic wave sensor. Barometer right inside the electronics enclosure. In fact, it's one of our most expensive and most valuable measurements. We want to have a really good pressure measurement, so this data gets great use by numerical weather prediction, climate models, that sort of thing. And this is what it looks like when we're out in the field. All right, how do you keep these things running? Well, we've been using solar panels and gel cell lead-acid batteries. They do very well. We used to build our own charge controllers right here with diodes and stuff right in the lab. We use commercial off-the-shelf charge controllers that do not too bad a job. And yes, at one time back in the 1980s, we actually powered them using radioisotope thermoelectric generators. Does anyone recognize what that means? Yes? It's a nuclear-powered device. Thank you very much for those who are nodding your heads going, wow, is it really that? Yeah, back in the 1980s, the weather stations used to be powered by a nuclear device. This has gone away. The United States decided no more nuclear devices in the Antarctic as a general United States policy, and they were all removed by 1994, 1995, I think the last was done. All right, how do we get the data back? How are you getting the information from these back here? And so communications has been basically via the Argos communication system. That's on board the older NOAA satellites up to NOAA 19. The new METOP satellites have a communication system for that on board. And Iridium. You heard of the satellite phone or familiar with that at all? That's what we use for a few of the stations, and we're starting to include more and more using this communication method. So that's what we're doing to talk to these systems. And these systems are low-power devices. Not much more than a watt of power to transmit data out. I think our fanciest systems that we've ever done in collaboration with some other grantees who've had chemistry-type instruments, maybe we've had a couple of systems with 5-watt systems, but that's it. We're very low. One of the lowest power autonomous systems in the Antarctic that's running. Our new project has been to build a brand new electronics core. The Wisconsin-1As and 2B systems were homemade here in the building by SSEC, and we had that knowledge right down to the resistor of what was going on. We now can't build that anymore. All the components for that are Pioneer spacecraft version technology. That's before Voyager. That's how old that was. It was great because it was military spec. It worked fabulous in the cold, right? But you just can't buy it. So we use commercial off-the-shelf systems today, but they're a black box. If something breaks inside them, I don't know. I can't tell you what took place. And I didn't appreciate it much until we did a paper with Dave Bromwich, another alumnus from UW-Madison, about some real serious warming that took place in central West Antarctica. We could take that station on the bench in our lab upstairs here and check to the resistor and find some problems with it and fix that data really well. And it made me say, hey, we really need to get back to that. This is it. We've collaborated with Madison collaboration with Madison College to build a brand new electronics core system. This is it here. We in fact just got a third version of it. This is the second version of it that you're seeing here. And the idea was to be able to collect all the same information and us know everything about what we programmed on it. As soon as we can get it to do just the right things with power draw and a few other bits, we're looking forward to trying this out again. If not this season, probably next we'll start getting these out there. We've already been testing an older version to see how they work. And here, we didn't build components, that were mil-spec for minus 80 degrees Celsius. It's what was available on the market. And it's amazing what's out there, even though nothing says it's spec to work below minus 40. We stuck it in a minus 85 degrees freezer that we have out at the college, and these things worked at that temperature. We're really impressed to find things out there that will hold up to that kind of cold. And we're excited about that prospect. We have done a couple of special projects where we build, instead of our standard weather station, which is about 3 meters tall, maybe some are close to 4 or 5. Right, Dave? You did a couple up to 5, I think. We have a couple that are 30-meter towers, 100-foot towers. So here's one, Alexander Tall Tower UW-AOS. It's been installed for quite a while now in Antarctica. And it's got 6 levels of measurement. And as soon as we can get past the problems with the pandemic and we get out to West Antarctica, we're going to install a second one. Disciple Dome is going to have a ton of the tower that will match that. We're doing this work in collaboration with John Cassano at University of Colorado Boulder, another UW alumnus, who we've been collaborating with for many years on looking at how the boundary layer behaves in the Antarctic. And we can get these measurements very close to the ground in collaboration with his UAV work, so we can get a really good sense of how these things operate, which is really exciting to us. One of the things I've enjoyed doing is collecting anyone who has an automatic weather station in Antarctica. This is not staffed stations, not where people are, but where an automatic weather station is. This is every nation, everybody I know about. And does this look like a lot? Show of hands, who thinks this looks like a lot of stations? Anyone? Oh, a couple of you think it looks like a lot. If we actually, now remember, this is Antarctica. The United States, continental United States, would fit inside the borders here, right? And there'd be room to stuff in Mexico on top of that. If I showed you the amount of automatic observing we do here, the map would be colored in. We have big gaps where we don't have any knowledge of any kind. Everything here is printed big, right? The triangles are big, the labels are large. If I showed you this to scale, you would have a hard time reading all the locations because there's so much void between them. So please don't be fooled by that. I usually get teased about the forest of weather stations, and I'm only willing to agree to like the inset maps. That's about the only places where, yeah, we have a lot of observing there, and that's about it. The rest of these places are pretty empty. Now, please note, the collection that I'm responsible for is this. This is about 1/3 to maybe 40% of what you just saw on the prior map we do. All of the red triangles, my team is responsible with directly, and we collaborate with other nations to do work with other folks, including France, Japan, the United Kingdom. We even do one with Australia, to give you a sense of the fact that this is an international collaboration. We could not do all this work alone. And that's one of the things I find exciting about working in Antarctica is we have great relationships with scientists from all over. And it's a really enjoyable part of the work, at least for me, very rewarding indeed. So, what are you doing when you're there? And I like to give credits to Carol Costanza, a former member of my group, also a UW alum, who's now, she works at NCAR at the UL lab. This is what we're doing. These weather stations very slowly get buried with snow. And so what we have to do on a routine basis is pull all the instruments off, dig them out, put a new tower section on, and then what you're seeing here in this video clip is put all the instrumentation back on the tower. And oh, by the way, you have less than 4 hours to do it. Because our ground time, when we've flown out someplace, or here we actually have the luxury of snowmobiles, is limited. And so this is one of the jobs that we get to do when we're out in the field, is this kind of thing. Not all of our sites are in pure snow like this. There's a few that are out on rock, and you don't have to worry about this, although generally we have other problems when we're there. Right? If it's a rocky site, that means it's most of the time, with minor exception, extremely windy, so therefore the sensors are damaged. just about every time we go to visit. We always have to replace everything for sensors because they're wrecked. But in any case, this is what we typically do when we're out there doing our work. Okay, there are other challenges. The weather itself is a big problem. This is a bad day, right? Here you're seeing a weather station that's literally melting out. This was at Pegasus North, which was near one of the main US flight airfields. It just finally got melty out there, we couldn't keep it there. Some places the weather held us back, so it literally took one of our prior gentlemen in the team 3 days worth of work. It took him over 30 days of waiting in West Antarctica to go out and do that 3 days worth of work. Or worse, that new tall tower weather station back in about, like I said, it's been out there about a decade now. It took a couple of years to get those installed, you know? It's just ridiculous how weather itself can hold you back. So there's a need for patience. There's the fact that you have to realize you're in a collaborative environment, right? The airframes that you are using are used by all kinds of other scientists. It's not just meteorologists. In fact, there are times when I'm in Antarctica that we're the only meteorologists there doing field work, and we're working with folks who are doing geophysics or biology work or oceanography or whatever. And everyone has to compete and collaborate to make use of those resources. Oh, this is a bad day too. So here we're looking at the top of one of the weather station sites that got blown off. Literally, the wind here was so strong, it backed off bolts, screws that held the bolts on to keep this I-beam. It's an aluminum I-beam. They backed them off so they opened up, so it wasn't screwed onto it anymore. It lifted it off the top of the tower, and as you can see, it blew it quite a long ways, right, to the end of the chain that holds this up. So that's like from where I'm standing to more than 3/4 way down the room. And it was blown in the wind. So that's pretty impressive. What's amazing is that these sensors, these are high wind anemometers, they were in such well-built shape, we were able to reuse those. They were not damaged. I was super impressed. So this is one of our other better investments, is we found fabulous sensors over the years to use. And this one here by the gentleman of Taylor, who's in the Seattle area, builds great stuff, and I will miss him the day he retires because nobody builds a wind sensor like he does. Obviously, there's a lot of day-to-day work, data requests, data processing. We have to quality control our data, right? If you don't want to use it, you'd prefer it if we took out all the bad numbers, right? And there are a few now and again that's really annoying to work with. We spend and invest quite a bit of time to take care of that. It has been a career for some folks in my team, including Linda Keller, an emeritus member of the AOS department. Dave here has been doing a lot of that work, and it's something that we've been very proud to provide to the community. Here you can actually see George working on the older, this is what the 2D electronics look like, if you wanted to see what they kind of look like. So it has all the same bits and pieces that science comes with, in addition to running a huge network, by the way. So yes, I still have to run proposals and publish papers and all that good stuff too. So who's going this year? I'm very excited to announce to you this is the very first year that we're going to have our first all-female team. Something that has been long overdue, and I'm thrilled that it's worked out that way. So we have Taylor Norton and we have Angie Montgomery who are going to be going in our first segment of the season. They'll do a handoff. They're going to be leaving very soon, actually, right at the end of the month. And then we'll be having, at the beginning of December, we'll have a switch off where we're going to have Lee Wellhouse from my team join up with my collaborator at the University of Colorado. It's a lot of the second team to do work in the Western part. So these are the folks who are going this year, so if you're kind of curious. All right, let's have a word about seasons. And I'm going to get on my soapbox and tell you why I think doing 3-month seasons into Antarctica is a bad choice. This is Marble Point AWS. This is actually some work that Ethan Delkin, my team, has been working on, putting together a report on Marble Point. It's been asked about by I don't know how many people in the last 20 years keep asking me about Marble Point and wanting to get a weather station in climatology. So let's build one. Here it is. This is the mean temperatures by month. Take a look. We have 2 months that are clearly summer at this location. Right? Warm temperatures, you get close to freezing. This is one of the few spots in Antarctica that melt out, right? So it's just rock around it for the most part. Makes sense. Notice the transitions, right? We get this 2 periods of time where there's a quick transition out of summer into winter or out of winter into summer. All right, there's your spring and fall. I buy that. What is interesting is the fact that we have not only a first part of winter, but we also have a second part of winter. And so these months end up correlating to what we are starting to awfully see in most of our automatic weather station data in the Antarctic, is that there is indeed this winter 1 and 2 period. So please don't use DJF as a summer or winter for the Antarctic. It's a bad choice because it doesn't match up with what's actually happening with the data itself. It's been kind of fun having the data inform us of what we see it behaving like down there. And this is one of those things that we're noticing. Shall we talk about some extremes now that we've talked the little means? This is the coldest temperature the network has ever recorded in its entire history, 120 below Fahrenheit, minus 84 C. I'll tell you what the record is for the continent in a moment if you don't remember, but notice it was back in the 80s. Boy, is it hard getting a record cold in a warming world. I'm trying. I really want to break the record cold, but it's difficult to do that. Stay tuned, maybe someday. The highest temperature our network has ever recorded, 2 spots tied for this. Once again, Bonaparte Point, AWS on the Antarctic Peninsula, melts out every year, makes sense. We were surprised that D10 AWS, which is on snow, but it is only about 10 kilometers from the coast, is a spot that actually got equally as warm, which is really impressive. One of the windiest places on average in Antarctica is this place called Cape Denison. Has anyone seen the famous pictures of Sir Douglas Mawson? He's a famous Antarctic explorer from the heroic age. He's literally like tipped over into the wind. He's like almost going to pick him up and carry him away. It's actually taken at his hut. We have an automatic weather station there that we do jointly with the Mawson's Hut Foundation in Australia. One of our windiest places, literally having somewhere between 18 to 27 meters per second, right? So almost into the 60 mile an hour average for the month. Wow, that's a lot of wind. But interestingly enough, not our highest wind speed location. The place where I showed you the anemometer that blew off, that has the highest wind speed. There you go, 137 miles an hour. Whee! Now you know why we have that downward chain. We have everything guide down in some fashion. And that was quite a while ago. It's been over 21 years since we broke that record there. Now, I was ecstatic to be included in a group, part of the World Meteorological Organization. There's an ad hoc group that gets together to review records. And as a part of that group, we reviewed some of the warmest temperatures recorded on the continent. So if you look at the Antarctic, it includes everything south of 60 south. So that means, when you include that, islands are a part of the grouping. And sure enough, the British have an island in Sydney Research Station's out on an island, has the warmest temperature at 67 Fahrenheit. Okay, it's really far out here in the middle of the ocean. What about what's touching the continent? The team of scientists wanted to know where's the warmest temperature there. Well, when you look at that, it turns out to be coming from an Argentine research base, Esperanza. And it's recent, March 2015, which was a really big deal. It got reported, and there was always hope that it would get investigated, and it finally did. And by the way, there's been challenge to this too, and I've been a part of the research groups that have been asked to review the challenges to it. We found some of other spots that have like second highest temperature since, but they haven't broken this officially. That remains the highest temperature content on the actual contiguous continent. And I was impressed. The team, not me, I did not bring this up, honestly. Someone asked, what about the rest of the fact that Antarctica, inside this blue line, that is all area that is higher than 2.5 kilometers. What about a high temperature in that range? Because Antarctica, not only is it the coldest and driest continent in the world, but it's also the highest on average. And sure enough, I was amazed when we went pawing through the data. It turns out, here it is, UW-Madison's weather station at D80, when Dr. Stearns had that running there, has the record. I was amazed. They're at 19 Fahrenheit, minus 7 Celsius. And it holds the record. It's funny, that station is no longer there. We moved it many, 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 many years ago to a place called D85. So it's in the neighborhood, but it's not at the same location. The French moved the location that they could service it, and so that changed. By the way, if you're curious just to know what's the other end of the extremes, as I promised, the coldest ever recorded on the planet Earth and in Antarctica is here at Vostok Station at minus 128.6 Fahrenheit. That's here at the blue square. and that still holds as the record for the moment for the coldest on the planet. So there's some extremes for it. We've had the opportunity over the years to do some really nice work in my team. So Linda Keller and I worked with the South Pole Meteorology Office to do their first ever comprehensive climatology study. I was thrilled to do this because now it's documented there, and we get a great history, especially where it gave us, yes, a 50-year review, which was kind of neat. And then I'm sorry the gentleman who published this didn't even know about it. But when we published our work, we couldn't prove any warming. And these folks, 10 years later, with 10 more years of data, look what they were able to show. You can just see it without spending the time to go through all the statistics and interesting math. And here it is. You can literally almost just see out the mean temperatures at South Pole Station are up. And it's significant, and that's a big deal. We weren't seeing that so much in the Antarctic, and now as we kind of pick through the data with more recent information, more sites are starting to show change. And this is one. Please note, not all of it's going to be warming. This is South Pole Station winter. So this is multi-month, right? This is April through September. All of those months together are their winter. And up until now, this was the coldest they'd ever been in winter. By the way, notice the high variability. Look at how highly variable it is. This is not uncommon to see in the Antarctic. And by the way, one of the things that's kind of wild is notice the variability's gotten worse. You know, this is when we first started observing the Antarctic, right? 1957, International Geophysical Year. Not that much variability, and notice it's changing a lot. It's really, really got a lot of high variability to it. And this is how you end up, by the way, on the BBC. I did. Sure enough, not this past winter, but the winter before, they broke that record, -61 by 4/10 of a degree Celsius. Coldest winter ever at South Pole Station. So it's not that cold doesn't still happen. The question is, will it happen less in a warmer world, right? So record cold still take place. There's proof of it. Quite interesting. We like to keep monitor of our weather station data real time. This is one of our real-time displays. And I purposely did something here that you should never do in a presentation. It is impossible for anyone to read any of the labels on the side and the back, correct? Can you see them, Andrew? No, you can't read them. Okay, good. He did that on purpose. How to have a terrible talk. Don't do this. What caught us at the time of big surprise was, hey, this is going up a lot. And you go, well, I have no idea if that's a lot or not. Well, it turns out it's dramatic. And to give you an idea of how dramatic this is, we're going to talk about this weather station site here, Dome Concordia 2 or Dome C2 weather station. Here's East Antarctic coast. So this is quite a ways inland, high up on the top of the East Antarctic ice sheet. And to tell you what took place this specific day, there it is. This is Dome Concordia's temperature daily high through a huge period of time. This is like the 1990 to 2020 or 2022. And their daily normals. And you can see how much out of the ordinary this one period of time was for temperatures. In fact, there is a possibility it might be the world record for excess of temperature ever. That is yet to be evaluated, I have no idea. The paper that this is going to be a part of is, there's a author list that's as big as this room. We're hopefully going to get submitted very soon, stay tuned. But it is a massive event. This broke records like we've never seen before on the East Antarctic ice sheet. And check it out, it's March. The sun is not up, and we've had warm temperatures here. That is unbelievable. So, as I was introduced noting, one of the things we make is satellite composites, and I'll talk more about these in a minute. Just to orientate everyone on the picture, here's New Zealand in the corner, South Pole in the middle, South America is off to the side here, right? Madison's way over here someplace. Here's the line of weather stations that we're going to look at. In fact, these are the different weather stations here. And the time we're showing you is this line. Thank you very much for Dave McBlychuk for making this excellent display. And when we put this together, just pausing through time, watch the cloud sequence. This is infrared satellite cloud imagery. And I've even hinted with a few arrows at what's happening. And as you watch time go by, what are you seeing? Oh, yes. Look at all those clouds coming into the East Antarctic, right over our scene. Here we are with our most warming taking place right about now. Now, remember, everything in an infrared image, it's white is cold. And everything that's grays is warm. And you're not seeing much white in this part of the ice sheet that would otherwise be that way if it were clear skies. So there's a lot of cloudy activity. We've invented massive amounts there on top of the continent. This would otherwise be known as an atmospheric river, if it fits that formal definition. And you can certainly see it in the cloud field that it shows up quite well. It's very impressive. In fact, I love the curly Q we get out of the system, by the way. What's wild about this too is the barometer goes up. Did you see that's what the blue line is? The temperatures are in red, the blues are the temperature of the barometer. How many people expect the barometer to go up with stormy weather comes in? Probably nobody. Dr. Stearns had a colleague who since passed away. His name was Austin Hogan, well-known South Pole meteorologist, who used to warn people of a rising barometer. There it is. This is why you're worried about it, because you're pushing all this mass up onto the ice shelf, and up onto the ice sheet even, all this air mass, and it's causing the pressure to go up, even though it does not contain in it good weather. It does not. And it was really interesting to see this take place. I think at the same time there was reports of rain on the coast, and one of the ice shelves on the coast calved off and broke up. I was probably going to anyways. It was just a matter of time, but this happened to be coinciding, which was very interesting. This is how much out of sequence this was for normal. The temperature here was minus 9.4, the ultimate high temperature for this site ever. We've been recording temperatures at this location for 42 years, and it broke the record in March with no sun up. That is 6 standard deviations above the mean, which is unbelievable, okay? The same at lots of other weather station sites along that line towards the coast. D47 was 4 standard deviations above, D10 was 3. Angle 4, which is up further away, was 4.7 standard deviation away. It's just unbelievable, just amazing amount of warming this event had. It's just impressive. I'd like to give you a small sample of some of the other science we've done recently, these are published works. One, I was excited that was started by an undergraduate in my team. You may remember Katie, now Maloney, now with Bailey, by the way. I don't know if you knew that, just that one. This was events of cold events, cold streaks at South Pole Station, and how long they lasted. Linda Keller had the chance to kind of finish some of this work, and we're very interested to see how they've been changing since the 1957 period to present. They would go through periods of increase, and then they would kind of drop down, and then they would go through an increase again, and now we're seeing the durations of cold spells decrease a bit at pole, which is kind of interesting. Or here's another that surprised me. We use radiation shields around our temperature sensors to make sure they keep the sun out. It's a problem when measuring temperature on the ice shelf or the ice sheets because, oh yeah, low wind situations with lots of sun, they anomalously warm up. And it makes one of the quality control issues a big issue for us. We have to get rid of that bad data. So we like to put shields on them to keep the sun out. Well, none of these are good, by the way. They all have problems. It's great because it guarantees someone job security to go correct all that data, right, Dave? But they have problems. This is the tin can, we affectionately call it the Chuck Stearns tin can, that we were afraid didn't really do a great job. And we switched to these gill shields, thinking they were going to be better. Now, the best way to handle this is to have aspiration. Actually get a fan in there, blowing stuff through. And that way you get fresh air in there all the time, you never have a problem. I don't have that kind of power. Remember, I'm in Antarctica, I have no place to plug in. It's limited. So since I can't aspirate and I don't have that kind of power, we're looking for best shield that we can find. We had thought these were better. And there was a study we did with the French a while back, thinking that was probably okay. We worked with our Japanese colleagues. They proved that these aren't so bad and may be very correctable. And that made me very happy. And now makes us think about this problem all differently. We just published on it, so Chuck would be ecstatic if he knew that what he was using for a radiation shield wasn't too shabby. Here's another work that we did, looking at atmospheric river event from the 1989 time period. You know, atmospheric rivers are not new. They've been hanging around a long while. And yes, that is NOAA 10 data. I'm very excited that we have tools in this building, like Coldest, that allow me to work with NOAA 10 data without thinking about it. It's fantastic. this past year has seen the end of a multi-year project called Year of Polar Prediction. And our interest has been in particular with the Southern Hemisphere. Our role in participating was to provide a community of us data and information, whether it be satellite composites, polar snapshots, our weather station data, forecast discussions. We were the communicative relay for that. Because we wanted to have our community, the Antarctic, collect more weather balloon launch data so we could do better predictions. Now, we all don't have, in all of our community, just a lot of free weather balloons hanging around. They're very expensive for us. Not every country has the ability to just keep doing that kind of collection. So we had to forecast when we could make those extra weather balloon launches. Then we'd collect that data and use it to determine if we could really improve forecasting of big cyclones, atmospheric river events, etc. And so that was our role here in this project that just ended. We did it for 5 months. My team and I, literally every day, someone in my team or myself was posting information to provide to this group of folks, international folks, so they could actually make those decisions, make a call. Yep, we need to go off, make extra weather balloon launches so people on the ice could spend the time to do that. I think it was last season, right, Dave? We had very excited about the fact that there was a total eclipse in Antarctica. And it turns out it was going to pass through an area where there are a lot of automatic weather stations. So we've been collaborating with a fellow in Chile, Rene Girardot, and we've been excited to work with Rene on actually seeing, did the temperature drop at all of our weather stations when the total eclipse took place? And so there are not only our own weather stations, here's somebody else's, and there's the total eclipse taking place. Did that happen? And so sure enough, we've had a look. In the kind of tannish color here, this is what the solar profile should look like at a variety of automatic weather station sites along the area where the actual eclipse took place. Many of these sites, not all of them, are our weather stations. The actual weather observed for temperature is in the blue, and we were ecstatic to see, look at the bytes in almost every single piece of observational data here. All of those bytes match with when the total eclipse took place. Yes, you can cool Antarctica by putting shade over the sun. It works. Isn't that interesting? You want to hear about this volcanic eruption in Tonga? Yeah. Can you see the data? There it is. When we first saw this, Linda Keller thought for sure the data was bad and removed it. We were like, oh, no, put it back in. It's correct. The data's right. That really is correct. So there's 2 other stations, Lifetime and Marble Point. And I was excited, by the way, the second blip shows through when it went through a second time. Here are some others that are dramatic, like Harry AWS. There's the first, there's the second, and that's not bad, seeing it over a broader range of values. Dome Fuji AWS Relay Station, these are in East Antarctica. They showed it very well. The data is a little more blocky, but it's definitely there. You could not miss it. So yeah, we're right along with the rest of the world observing this event. It's hard not to miss. We have it. Boy, I love these pictures. And the purity, I love this. By the way, if you're wondering, where's Antarctica? It's here. There's an iceberg that's about the size of southern Wisconsin. That gives you some scale to how big this synoptic cyclone is in the Southern Ocean. Isn't that huge? It's just amazing. It's one of my favorite Polaroid pictures I've ever put together. So yes, as noted, we are also known for making this. This is an Antarctic composite satellite image. It uses every piece of data that comes into this building on the dishes, on the roof, down the street, across the way, and on the internet from Antarctica. And we make them like a jigsaw puzzle right over the Antarctic. And we don't use any older synthetics data, so that's why there's always a little gap in it, because we never quite get full coverage. And so it gives us a great view, as good as it would be as if we could get geostationary-like data looking over the Antarctic and Southern Ocean. You can see the evolution of storm systems and such, which is really, really great. It's used for weather forecasting, used for education, and of course research. One of the things that we're excited about is we also feel it can also do what we think are cloud mouse transport events. We think that these are basically the superset of atmospheric ripples. And not only can you see it in the infrared, but you can also see them here in the water vapor imagery as well, which gives you an upper tropospheric view of the water content that's there. You've all probably heard Dave McGlychuk just last spring defend his master's thesis, where he worked on these austral winter warming events. In winter, this is warming going on in the winter time. And we were ecstatic to discover these because we're like, wow, this is amazing. Once again, sun's not up, seeing big changes in temperature, right, over 30 degrees Celsius in very short periods of time, 5 days or less, right? So, and it's not being driven by the sun. There's other stuff happening here to make that go. I won't get into all the details here. Dave has a lovely presentation. Did it get recorded, Dave? I think it did. But here is one of those examples where we, looking through our data as we do our quality control processes, when we go, wow, look at this. And when you focus in on just that time period, here we are looking over a 3-4 day period, you can see that jump, less than minus 50 Celsius. Now we're here about minus 15 Celsius in that short period of time. That's tremendous, right? So there's a lot here. 70-degree Fahrenheit warming, by the way. That's what we're talking about here. Big spaces, just impressive. And it's really interesting that you get some neat weather patterns to take place to make this go. And so Dave, like I said, chatted all about that, and that's one of the kinds of science projects where we've really married our weather station data, our satellite composites, and then leverage existing tools, reanalysis, et cetera, to really understand how things run in the Antarctic. Okay, everyone got their phone? Get your phone out. No? It's okay, go on. We do have the QR code there if you want it. We finally got funded to do something that Dr. Stearns wanted. He wanted it desperately. He wanted to be able to sit at his computer and get all kinds of weather information about Antarctica right here with ease. And when he told me that, it was something that wasn't that possible because not everyone shared, and wasn't always around digitally, and it was a huge problem. Well, we're finally getting the chance to do that thanks to funding from the National Science Foundation. We're built a data repository. It's formal, it's joint between Madison College and UW-Madison. The actual repository lives here, and we're excited about having the ability now where you can go to this site, get data that's here, and we're actually adding records constantly. So it's not done. This is a work in progress. I think we have several thousand sets of data here. They fit the official needs of being findable, accessible, interoperable, and reusable, the FAIR standards. And when it's our own data, we can issue our own digital object identifier. We're really excited about that. We also are going to be taking in data from other investigators. If you've got a data set that's Antarctic, I'm your library for it. Contact me, love to chat. One of the things we're cool about here is we've got the neat map where you can click on things and learn about stuff. You'll also notice we have these green pluses. We've started to add links to everybody else's data as well. We're not going to hold it, we're not going to have a copy of it, but we will have a copy of their metadata record. So you can come to us, discover their data, and then go to their repository. And we've started to find some, 91 already. And we're going out to places like the Australian Antarctic Data Center, the National Institute of Polar Research in Japan, etc. This has been something that was funded by SCAR, that Scientific Committee on Antarctic Research. They have this Ant Climb Now project that literally wanted people to do, not creation of new things, but be able to do stewardship and synergy of data sets. And that's one of the things we've been doing. We plan to continue this on as far as we can go. We'll be collecting lots more of these. We'll be doubling this, I'm sure, in the next several months, which is exciting. All right, should we see what it's like to go to the ice? And some picture, this will be fun. So here we are, this is one of my last deployments. Yes, we fly down with the Air Guard from New York. They fly these skied LC-130 aircraft. That's what the L stands for, is ski, unlike W, which is weather, L for ski. I love the military. I have no idea why it's called L. And if we're not flying with them, we're flying with the 62nd Air Force out of Accord. I think those guys like taking us down rather than going elsewhere in the world. And so yes, you can actually land wheels outside McMurdo for most of the year. There's some periods when you really can't do that, which is kind of cool. And this is the view you get. Anyone know what are we looking at here? Anyone take a guess? What is this?
It's Mount Erebus.
Yeah, Mount Erebus. And it's a volcano. Yes, the southernmost active volcano in the world. Brilliant place to set up establish a research base, isn't it? It's great, by the way, if you're a geologist, man, this is fun, right? They love studying it, they have a good time. It's not like Kilauea that has a big active molten lava pit in it. It's just the smoke and the steam. It looks fun and interesting, and that's about all. This is the largest station in Antarctica. So this is like the New York City of Antarctica. McMurdo Station, U.S. main station. It holds about 1,100 to 1,300 people in the summertime, which is pushing it. It holds about 200, 250 in the wintertime. And the US, by the way, is going to be rebuilding it because a lot of it is dated. So stay tuned, it's coming up. We'll get rebuilding soon. It is also the southernmost place in the world you can sail a ship. So this is how they resupply a station by vessel, both for fuel and for cargo. You can see the cargo ship here. It is also where, at the tip here of that peninsula, is where Scott's hut is still there from the heroic era of the exploration of the Antarctic at the turn of the century. And by the way, that hut is left in the exact same condition that Scott left it in. All the food and all the whale blubber and all, it's all there, untouched. And it's just as fresh and as lovely as it was when we left it. By the way, it's a lesson in throwing things away in Antarctica, because if you throw something away in Antarctica, it will be there forever. In fact, the United States used to, in the battle days, did open dumping. Now they cleaned it all up because nothing rots, nothing goes away, right? So everything gets recycled in Antarctica. It's a huge issue. So anyways, by the way, this is really neat view. Thank you, Dave, for this picture, because wow, it doesn't know we melt out and get that stormy out there. And this is one of the few years that it does. Usually a lot of this gets very nice thing. We do take a lot of smaller aircraft, these twin otter aircraft, to get to a lot of our weather station sites. That's a really common way for us to get around. Some of the ways we go is helicopter, whether they be Squirrel helicopters or Huey aircraft, Bell 212s. And they get us like this one here, and they get us around to a lot of our sites as well. Don't I look happy in this picture? I look so happy. I really wasn't that happy because when I jumped out of the piston blade, this is a track vehicle, I was up to my hip in snow, and we didn't have enough fuel to get to the weather station site. It was so fluffy, the snow was just so much, there was no way. So we're sitting here analyzing it, and I'm like, what's going on here? I wasn't too happy. And that's just how, actually we had a great time though. Right, that was fun, it just didn't work out. This is a bad day. How well do you think the temperature relative humidity measurements are here?
I guess it's about 32.
Yeah, it's terrible, right? Yeah. Because we're now measuring what's going on with the ice and not the air. And this is one of the problems we have. This is a pain because determining this when you call it control data is tough. It's easier when this ice is up because it's obvious, right? Okay, the wind direction quit, right? Because it's now the same direction. It's been like that for days. You know it's frozen up, or the propeller has frozen up and you now get 0 for wind speed. But these things happen, right? These are some of the, this is a bad day. This is that, once again, Minna Bluff site, and it gets into the clouds, and when it's super cooled liquid, right, hits it, it all rhymes on it, and you get this total encasement. It's just crazy. So we fixed it. It looks a lot better now, and I left it. It still rhymes up the whole time. I think just about every year now it's rhyming up. And probably doing it more so than it ever did in the past, which is also an interesting sign of change. Kind of interesting in that regard. Lovely place for atmospheric optics. If anyone's into atmospheric optics, the University of Wisconsin-Milwaukee had a famed professor, Professor Greenman, right? Who did atmospheric optic work in the Antarctic for years. He's actually retired, and I actually saw him before the pandemic, living in the Madison area. I was actually thrilled. He gave a presentation like this, and he asked me a question that only someone who went to South Pole would know. He said, have you been to South Pole and been a member of the 300 Club? And I'm like, wow, how does he know that? And we'll talk about what that is later if you really, really want to know, but I was surprised. Great place for optics, right? You're at the right kind of place with the right kind of ice crystals in the air and the low sun angle. It's just amazing. What's this? You recognize, Stefan, you know what it is? No? Anyone recognize what this is? Looks like what? Seagull. In Antarctica, they're called skua. They're scavengers. So we're the skua of meteorological data, right? That's what I do. We scavenge with before they go. Be careful of skua Sam here. If you come out of the galley with your food, they'll come after you because they like your food very much. And this, right? Seal. Plenty of those running around. These are the kind of the docile, crab eater seals or Liddell seals that are around. The leopard seals are the problem, right? So that's why it can't be just black and white next to the ice edge, because then they'll think of penguin and lunch, which is not a good thing, right? And of course, we could not come and give a presentation on Antarctica and not show you. We have a couple of sites that are close to penguin rookeries. One is actually in a protected area. It's our only site that we have to carry a permit to go to. All the rest of our weather station sites are not in a protected area, and one's like on the edge of one, so we can look in. But it's pretty impressive. By the way, the penguins, they look cute, right? Very loud, pretty smelly, just so you know. But they really get into it here, as you can see. It's kind of interesting. Okay, did everyone see the penguins in the distance? No? Here they are. Here are the penguins in the distance right here. Why do you think they're staying away from the ice edge? Let's see if you can all determine why that might be the case. Why might they be way off from the ice edge?
Something's lurking, waiting for him.
John's got the right clue. Something's lurking. Let's see if you can figure out what it is that's lurking for them.
Killer whale.
Yes. Right on. You see them all rising here. Yep. Yep. You'll see them over here. Those are all orca, the killer whale, right? They do like penguin for lunch, which is a problem. And so it's good that they're keeping their distance on
Do they
purpose.
swim under the ice and bust through? Or?
They can do all kinds of organized.
Awesome.
They'll even get organized where the orcas will get up and then try to tip over an ice floe to get them to slide off
Yeah,
and get into
yeah.
the water. Yeah.
Wow.
Think about that. That's impressive that they'll be that organized about it. They really will. I think even the original explorations by Scott and Shackleton ran into that problem where they would be on the ice floes and the orca would go after them. Yeah, do the same. Some of the cloud features are just fantastic. This is a fabulous one with the lenticular. I've taken a few pictures. Dave's got this one here that are very similar. With such tall topography, Mount Discovery here, this is like a Rocky Mountain tall dormant volcano. It just provides a scene where you can have the air being forced over these features and produce tremendous looking cloud features like this. Just amazing. It really is impressive. This is like I think my best selfie I've ever taken. Partly because, well, yes, there's Dave. I was having a good day, and I was thrilled. This day in particular, we get the chance once in a while to take folks out in the field with us. A, because we could use the help. Anyone want to dig some snow in Antarctica? Anyone? Nobody? Oh, maybe one or two. Okay. We usually don't. We usually need that. And some folks go to Antarctica, and their job is to just be at McMurdo Station. They never leave and never see the rest of the continent. She did laundry. That was her job, and I felt terrible. And we were thrilled to have them along, and they love coming because they get out and see the Antarctica they were hoping to see. And so Sean, she was lovely to have with us this particular day, and I was really excited. Okay, does anyone know who this fellow might be that I had the chance to meet in the Antarctic? That's okay. I don't have expectations that you would all know, but I thought I would try. Who? This is indeed Sir Edmund Hillary. On his last trip to Antarctica the year before he passed away. Sir Edmund Hillary, of course, is known for what? What you all know him for doing?
Climbing Everest.
He was the first to climb Everest with Tenzing Norgay's, correct. But do you know what he was also famous for?
Third Treasure was Antarctica.
That is correct. And he is, of course, famed for that. And he loved going to Antarctica. He was so happy. And for not someone who didn't feel great, he was super happy being there. In fact, I flew out on the C-17 with him, and they let him up in the cockpit. We did things in the C-17 I didn't think we should be allowed to do in the C-17, so he had a good time on his last trip out. Anyone know who this gentleman is? This is even harder, and I wasn't expecting anyone to know this either, but I thought I'd throw it up there and realized.
It's more familiar.
Yeah, and probably a little. This is the Prince of Monaco.
Yeah, that's right.
Prince Albert of Monaco. Monaco has just signed the Antarctic Treaty. When he did so, his country did so, he said, I'm going to Antarctica, I want to see it. He spent a month there, and in 31 days saw 28 stations. We were the last set of stations he visited. He was exhausted, and he was so happy to sit and talk with me about climate and weather. If his people didn't kind of shoo him away to go have some sleep, he would have sat there and talked to me all night long. He was so enthusiastic about it. And that was just lovely and refreshing to run into. I've talked to you a whole lot here, and I'm really happy to stop at this point and take any questions that you might have, with thanks to a lot of the people who've supported us over the year, including the staff here at SSCC, staff at Madison College, like Amy, my main staff member there, folks at the various air groups, 109th, the 62nd, Ken Borg Air, PHI Helicopters, Antarctic Supports Contract, and of course the folks who fund us at the National Science Foundation. With that, thank you very much. I look forward to your questions.
Any student questions? Start with students.
What's the difference between winter 1 and winter 2?
Yeah, there's an actual change in the general mean temperatures between the two. We noticed that it's not quite as cold in the first half of the winter season, and then it dips down and gets a little bit colder. Most of the prior work that's been done, whether you're Wendler up in Alaska or some of the work that's been around, Parrish and Bromwich and others have talked about the kernelose or coreless winter. And they usually just show the temperatures going down and flattening out. But even some of those data, we've had to look back, and we've kind of seen a little bit of a hint of that separation. And we're seeing it basically anytime we go through, because our weather stations are now been out long enough that they're getting that 30-year record collection that you go, aha, 30 years, I can now run a climatology. And that's what we've started to notice, that they have that slight difference. It's not a lot, and it's not overly studied to death yet, but we notice that there is something there that makes them different. So yeah, I mean, just from I have to admit, I monitor my temperatures all the time in the Antarctic, and I notice, yeah, I'll get some early 100 below Fahrenheit temperatures at the beginning of winter, and it quits. And then I really don't have that until we get to like September. You know, and I can go to my classroom, and most days in the beginning of September, show my classes, oh yeah, there's a weather station temperature network in Antarctica, and there's always a minus 90 or 100 below most of the time, which is amazing. So, yeah. Yes?
In an ideal world, what would be a data set that you would like to collect?
In an ideal world, what's a data set I would like to collect?
Yeah.
That's a really good question. I mean, I'd almost, having what we have in a complete fashion would be lovely. You know, adding to this some of the fancier sensors would be neat, right? I just don't know. I know unfortunately, I think way too practically. I already know all the problems I'm going to run into when I think about that, right? Like, wouldn't it be great if we had, for example, the incoming and outgoing shortwave and longwave energy everywhere? Boy, the things we could do would be cool, right? That kind of stuff. Or some of the other fancier equipment. You know, we build nice sensors and neat things here at SSCC that I know we can't have around the continent just everywhere because it's expensive power lines. But those would be cool things to have, wouldn't they? Yeah, that'd be great. Yes, Brad?
So you said your batteries are buried.
That's correct. Yes, they are.
You know, it seems like if you're only solar power,
Yep.
how long do your batteries last, or do you still get enough low sun that you're able to collect?
We want the batteries buried because that way they go through less temperature ranges.
Right.
And so we get some batteries that can last 5-10 years.
I'm talking about like seasonally.
Oh, yeah, they actually, if we have enough capacity,
Right.
we can make sure that they don't get depleted so we don't ruin their capacitance on purpose, right? That's important because that's one of the things we've been running into a problem with the new PCWSs that we built, that they draw too much power and then they destroy the batteries because they drain them out so that then when the sun comes back up, they try to start up, but now at that point, your battery system is wrecked, right? And they don't have any capacity, so you have to replace them.
So you have enough sunlight during
Yep.
the sunlit
We
time
do.
to collect as much energy as you need for the
Yep,
winter.
absolutely. It's perfect. And so we've purposely staged, like for example, on the polar plateau, the highest latitudes, we're going to put 400 amp hour batteries rather than 2 or 3, and that gives us enough capacitance to make sure that we never drain them to death, and therefore they can completely recharge and keep running. Absolutely. Yes, John.
Matt, are there any high latitude, almost the same latitude, close to the North Pole instead, like at high altitude in the far northern Canadian Rockies, maybe even the mountains in Alaska, where you can have a coreless winter? Do we have any observations at any of these places that would be akin to these that would suggest the same thing can happen in the northern hemisphere?
Maybe.
This is a weird place, but it's
It is.
also sampled weirdly.
Yeah, true.
Right?
So we ran a network of weather stations, well, Dr. Stearns, I should say, ran a network of weather stations in Greenland for 10 years in the 1990s, and supported by scoring operations. That network was removed, and then Connie Steffen put in a new one, and now the Danes have their own as well. And so they're around. This data to be had, in other words, it's not been analyzed for that
Okay.
I'm aware of. But it could be done, and that would be interesting, because Greenland would be a good analog.
Yeah, Greenland, I didn't even think of that.
Yeah.
I was thinking of northern
Yeah.
Canada. You're right,
Yeah.
Greenland would be even better.
Probably best bet, and then we could see if it matched. I don't know if it would, but it may.
Yeah, and if it doesn't, that's kind of, you're sniffing into my question. If it doesn't, then that has something to do with the broad hemispheric circulation differences.
Probably, yes. That would be
And
next.
my guess would be it's wavy in the northern hemisphere for obvious reasons.
Yes, absolutely. Yes. Question?
Yeah, we know that in the Arctic, a lot of really, anytime that we get like really large amounts of moisture
Yep.
into the high latitudes, they're often associated with blocks.
Yep.
Do you know, given like the kind of the atmospheric river events that you showed, do you know if it's the same for the?
There are blocks associated, yeah, absolutely. That seems to be a part of the element in some of them, so for years, Chuck Stearns and I would sit and watch our composites. And we would watch westerly, 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 and all of a sudden, the pattern would change. Storms would then quit being westerly, but very, very, zonal. And they get very on, just totally vected into the continent. We did some work with Jess Stoddy, just run on that for her master's work. We've been trying to publish on it. It's always been a challenge because everyone wants to seem to have us tied to things like ENSO. Well, it's not going to, because those phenomena are only single, couple, 5-day events. They're not multi-month events, so why would ENSO tie into them? In fact, some people have published lately that told me they won't ever. But there is a blocking kind of thing going on where all of a sudden, those systems will no longer continue along, and then they get shunted around, and some of them do vect into the Antarctic directly, yes. And that gives you what? Bad weather and snowfall, and all, basically it's part of the P-E issue and the actual input to the ice sheet, pretty much. So glaciologists are kind of hot about that too, because it's one of the small terms they don't have figured out for their ice models and their issues. So they're kind of, the community's generally interested in that. All right. Any other questions? Very good. Thank you all very much. It was great having you come along.